Hello there, ROS developers, and welcome to this live class number 104. So today we are going to be talking a little bit on ROS2 basic concepts, specifically on how to create and work a little bit with packages, both in C++ and in Python. So let's start. All right, so welcome everybody. Yesterday we had some problems, so finally we are doing live class today. So welcome again everybody. And yes, as I have just said, today we are going to be talking on ROS2. We are going to change the topic to ROS2, and specifically we are going to be talking about packages. So how to create packages and how to work a little bit with packages, how they are structured, the different files they have, etc. And we are going to show examples and practice both with Python and C++. So, well, first of all, let me know in the chat if everything is fine, sound is fine, video is fine, so that I can continue. Hello, where did you get your t-shirt? Do you like it, Katai, my t-shirt? I'm a ROS developer. Well, my t-shirt, we create these t-shirts ourselves. Our company, the Construct, we create them, and you can buy them. I think the link it's down there in the video description, in the live description, so you are going to find the link there. Also now inside the project that I'm going to share with you, you are going to find all the information on how to get these t-shirts, these super nice t-shirts, and also these Macs, because I have also this Mac of I am a ROS developer, which I always carry with me. So let me see if everything is fine here. Sound and video are perfect. Excellent. Will this video be available on your channel after the live stream? Yes, Sirajudin. This video, when this live class finishes, it's going to be available as a regular video in our channel, so that you are going to be able to rewatch it as many times as you want. So yeah, let's get started. So let's not lose any more time. Everything is fine, sound fine, video is fine. So let's go for it. Then, as always, I'm going to start by sharing with you the project. So let's switch right now. Let me get here a drink on my super fancy Mac to get some energy. And now let's switch to my computer screen and let's start. All right. So here I'm already logged in ROS.ds, as you can see. And here I have prepared the project for today's live class, ROS Developers Live Class number 104. So let me very quickly grab here the link and paste it here into the chat. Let's go. All right, so there you go, have the project link. So as always, in case there's someone new, we are going to be working on the ROS Development Studio. So in case you already know it, just log in. In case you don't know it, you can just create an account for free, completely free, and in a few seconds. So create your account, log in, and then you just have to click on the link I have shared in the channel, or copy paste the link to the URL, whatever you want. The thing is that when you do so, you are going to receive this project into your workspace. Yeah, so you are going to have this project available in your project forever. So not only for this live class or for today, but you are going to have this project forever also. So you can review it tomorrow, next week, next year, anytime you want. Okay, then once all of you guys have this project, then we are going to open it by clicking here on the open project. So let's start opening this. This project might take a little bit longer than usual to load. Why? Because it's a ROS2 eloquent project, so we are going to be working with ROS2, as you can see. And these kind of projects usually take a little bit more of time to load than the regular ones, so just be patient. It might take, I don't know, maybe a couple of minutes to completely load, so let's just be patient, and meanwhile I'm going to talk with you. so that your waiting it's more pleasant, let's say. So let me talk with you as I always like to do. Then yeah, so today we're going to be talking on ROS2, and let me go to our academy, here in the ROS courses section. This is going to take you to our academy. Here I'm already logged in. I'm here with my picture of Yoda, and yeah, so this is our new academy. Yes, we last week we renewed a lot our academy, and we are going to renew it even more. Only you can feel that only with the look and how everything is looking, the organization and everything is completely new. But also the main thing is to be publishing new courses. Yeah, so this week, not next week, but this week, we are going to be publishing new courses. Yes, so for instance, a course on robot dynamics is going to be published. So, and more, stay tuned. Yeah, so this week, along this week, we are going to be publishing new courses, new super interesting courses into our academy. So remember to be checking it. And also, not this week, but very soon, in the next week, we are going to be publishing a course on ROS2 navigation. Yes. And this course on ROS2 navigation is going to be based on ROS2 Foxy. Yeah, so today we are going to be working with ROS2 Eloquent, as you can see. Yes, so this project it's based on Ubuntu 18 plus ROS2 Eloquent, but we are going to be very soon upgrading to ROS2 Foxy. And this new course is going to be working on ROS2 Foxy. Yes, so because of this new course and many more that we want to keep bringing to our academy, we are going to do some live classes these days on ROS2. Yes, so that you start to get familiar with ROS2, at least with some basic concepts. Maybe we are going to introduce also some more advanced concepts, we will see. But for now, at least today, we are going to keep it simple here, and we are going to work with ROS2 packages. So yeah, basically I wanted to talk about this, so stay tuned to our academy because many new features, new courses are going to be coming in the following days. Yeah, so let me go back to my project. Let me see if it has loaded. Excellent, so it has already loaded. Here we can see that my notebook is opening. So let's wait a few seconds until the notebook completely opens. Hopefully it's going to be the right one. I bet so. So let's see. It's still loading all the systems and everything. There we go. Alright, so it's the right one. Excellent. Okay, so yeah, once your project fully loads, as you can see, you are going to have a Jupyter notebook here automatically opened for you, which is going to contain here the notebook for today's live class. It's this one, live class number 104. Yes, this is going to contain all the instructions that we are going to be following today. So yeah, the first thing I want you to do is to open the project and wait until your project completely loads and you have here the Jupyter notebook automatically opened. So let me know, guys, if you are in this same point as I am right now, because I don't want to keep moving until you reach this point, so that you can start working with me as well. So I'm going to wait until you guys tell me that your project has been opened. So let me have a look here at the chat. When will be the ROS2 navigation course be released? Looking forward to that. Well, very soon. It could be next week, maybe, or in the following 2 weeks. In that span of time, it's going to be published. Zach, loaded, says Nation. Zach also still loading. Okay, so let's wait just a couple of minutes more so that the people who is still loading your project can have it loaded. Then yeah, so as always, I'm going to be following the instructions I have prepared here in my Jupyter notebook. then the idea is that you guys do the same as I do. Yes, you can do it at your pace, whatever, but the idea of this live class, my idea is that we practice all together. Yes, so I don't want you to stay there just watching the screen and seeing to what I am doing and listening to what I am saying, but I want you to be practicing with me. Yeah, so here I am going to be working, executing commands, creating files, etc. Then I want you to keep the pace with me. Yeah, so do the same as I do, because this way is how you are going to learn the most. Yes, by practicing, not by only listening. Yeah. In any case, if at some point you get lost or whatever, remember that you are going to still have this project after this live class finishes, so you can come back to this project anytime you want in order to finish it, whatever, to review it. And also the video is going to be there in our channel in case you want to rewatch it. Yes, but for now, for this live class, let's try to work all together. Let's see. So how it is going? It has loaded already? Yep, no? Let's see. Yes, okay. Okay, great. So let's go. Let's go for it then. Everybody has the project loaded. Here, sorry, but I cannot read your name. I'm very sorry. But I can see that you have an image of a lion there. So his project was loading, but now it's already loaded. So let's go for it. Let's go. Then, okay, so the first thing I'm going to do is to set up the environment, which means launching a simulation. Yes? Then for this, I'm going to open a new shell here. This is a regular Linux Ubuntu shell. Yep, and I'm going to execute the following commands. So first of all, I'm going to source the ROS version I want to work with, which is Eloquent. So I'm going to source my shell so that I can work with ROS2 and I can execute here ROS2 commands. So this is the first thing to do. Next thing is that I'm going to source this simulation workspace, which basically contains the simulation files, the gazebo simulation files. So let me source the simulation workspace. You can, let's open the IDE also now, because it's going to allow us to see all the files and everything in a graphical way, which is much more easy to work with than doing it from the shell. So here I have all my workspaces, and as you can see here, I have just sourced this simulation workspace, which is this one I have here, which contains packages related to the simulation. In this case, the simulation is from the Turtlebot 3. Yes, so I'm sourcing this workspace, and then I'm going to set some environment variables related to Gazebo, basically to set up properly the models and everything so that we can see the robot properly in Gazebo. We are going to also set here the Turtlebot 3 model, which in this case is going to be the waffle one. So we are going to be working with the Turtlebot 3 waffle. And finally, I'm going to execute the command here in order to start the simulation. The command is this one I have here, which is ROS2 launch Turtlebot 3 gazebo empty world.launch.py. Yes, so this is the command that is going to start my simulation. So let's execute it. I'm going to move it around here. And now what I'm going to do is to come again here to the tools menu and open a gazebo window. Yes, in this gazebo window is where I'm going to be able to see the simulation loaded. So let's open the gazebo window and let's wait until this command is executed. Here it's still loading. So let's wait a few seconds. Let's see. There it goes. Don't worry if you see some errors messages here. They are expected, so don't worry. It's normal. Sorry. So the thing you have to check is if the simulation loads here in the gazebo window. This is going to indicate if everything went okay or not. There it's going. Now there is a chance that in some cases this doesn't work properly. Yes, so I have added a note here at the end of, so if everything goes okay, you should see something like this here in the gazebo window. Yes, if everything goes fine, you should see here a Turtlebot 3 waffle robot in an empty world. If everything goes okay. Now there is a chance that something goes wrong, as I explained here in the notes under this section. Now in my case it seems like it has gone wrong, so I am going to show you how to fix it. Yes, now let me know for you guys, has it worked? Is it showing here the robot like in the picture or not? In my case it hasn't worked, which it's good. Let me say that it's good, because this way I'm going to be able to show you how to solve it, how to easily solve this. But in your case, guys, it has worked. No, the same loading screen. Okay, so you are in the same situation as me. It's saying loading simulation, please wait. Yep, the same as you, says Thanasis as well. Same. How do I bring up the gazebo screen? Asks Zach. Very easily. You have it, let me close it here. You have it here, Zach, in the tools. Here at the top left corner of the screen, you have this tools menu with many things, and here the first option is gazebo. This is going to open here a gazebo window. Okay? Now, I can see that you guys are having the same problem as I am, so let's see how to solve it. Okay, first of all, I'm going to terminate this command here with Ctrl-C. Okay? Just Ctrl-C to terminate this command. Okay, it has been terminated. Now, what do I need to do? I need to look for the GC server process. Why? Because although I have terminated this command here, this ROS2 launch command, GC server has not been terminated. So how do I do this? Using the ps command from Linux. Yeah. So I'm going to execute this ps faux, F-A-U-X. Now, oops, sorry, ps faux. Now I'm going to hit here the vertical pipe, and I'm going to put grep in order to filter the results, and GC server. Yeah. So ps, this command basically lists all the processes. Let me show it. So a ps command lists here, well, ps faux. Yes, so here it's listing all the processes that are running. Yeah, so now what I'm doing with this pipe here, sorry, what I am doing by adding here the pipe and grep GC server, what I am doing here is to filter the results of this command and only look for the GC server word. So by doing this, I can see the process which contains GC server. Yes, then here I can see that ignore this one which says color auto, ignore it, the first one. So the important one is this one, the second one. Yes, this GC server, verbose, home user simulation, whatever. Yeah, this is the important one. And as you can see, the PID of this process, it's this one, 3145. This is 3145. Yeah, so 3145. This is in my case. Yeah, probably in your case this number is going to be different. Yeah, in my case the process ID number, it's this one, 3145. So once you have this number, all you have to do is kill -9 and this number. In my case it's 3145. Yeah, in your case you have to see what number you have here. So now with this kill -9, what I'm going to do is to terminate this process. Yes, so now if I execute this command and I look for the process again, I'm going to see that I don't have any process which is named GC server. Well, I can see this one, the color auto, but this one doesn't matter, it's nothing. So we can see that this process has been terminated. It doesn't appear anymore here. So now once I have terminated the process, what I'm going to do is to execute again the ROS2 launch command. Yeah, so let me do it. I'm executing again the command, and as you can see, now it has loaded properly. Yes, so now I can see here my empty world with the Turtlebot 3 robot. Now it's working properly. Yes? Alright, now maybe it's going to take a little bit more for you to load, I don't know, but it should work. Yeah, let me see. Wonderful, says Amir Hamza. Yes, I also think it's wonderful, Amir. Okay, so did this work for you guys? Is it, can you see now the simulation and everything? In some cases, it might take some extra seconds to load all the meshes in Gazebo. Yes, yes. Also says Zach. Excellent. Okay, so let's keep going then. So we have fixed this issue. Then now let's keep going. So we have the simulation prepared. Then let's start. So first of all, what is a ROS package or a ROS2 package in this case? So basically the idea is it's the same in ROS2 and ROS1. Yes, so ROS uses packages to organize its programs. Yes, so you can think of a package as the files that a specific ROS program contains. So all the C++ files, Python files, configuration files, compilation files, launch files, etc., etc. Yes. Then every ROS program that you want to execute is organized in a package, and every ROS program that you create will have to be organized in a package. So every time you start working on a ROS project, the first thing you are going to do is to create a package. Yes, where you are going to place all the files of your project or whatever you are going to be doing. Yeah. Then let's start. As I've said, we are going to be working a little bit with C++ and Python packages. So let's start with the C++ ones. Then. Always. So when we want to create a package, we need to work in a very specific ROS workspace, which is known as the ROS workspace. Yes, this is the same as ROS1. Yes, so in ROS1 we also worked with workspaces. Yes, always the packages have to be contained inside a workspace. So okay, so now this shell, the one which has the simulation running, we can forget about it. So I'm going to just minimize it, and I'm going to open a new one to start working with this. So the first thing I'm going to need to do is to source the ROS version. In this case, it's Eloquent. Yeah. So I'm going to source the ROS version because I'm going to be working and I'm going to be executing ROS2 commands. So I need to source the proper ROS version, which in this case it's ROS2 Eloquent. Yeah. So now I'm going to go to my ROS workspace, to my ROS2 workspace in this case, which is called like this, ROS2 workspace. So I'm going to go there with a CD. Yeah. Now if I execute a pwd command, you are going to see that you are inside this ROS2 workspace folder. Yeah. Now this is the workspace, but inside the workspace you are going to usually have different folders. Yes. Here you can see the build, the install, the log. Yes. All these folders contain compiled files. Yeah. Things that are generated on compilation time, but the packages have to be placed inside the src folder of your workspace. Yes, so we need to go to the src folder inside our ROS2 workspace. Now here we are going to see that currently it is empty. Yes, this src folder is empty. So what we are going to do now is to create a package. Then here we have the command used in order to create a package in ROS2 for C++. Yes, so I'm going to copy and paste it here, and I will analyze it now. So now I'm going to execute this command, and this is going to automatically start creating my package. So now if I do an ls again, I'm going to see this my C++ package. Yes, also in the IDE, if I open here the ROS2 workspace src folder, I'm going to see here my package, my cpp package, which has been just created. Yeah. Now, yeah, yeah, so how does this command work? Well, super easy. So first we put the key words here, which are ROS2 package pkg create. Yes, these are the keywords, ROS2 package create. Then next thing is that we specify the package name. Which name do we want to give to our package? Well, in our case, it's my CPP package. Yes. Next thing is we specify the build type. Yes. In this case, it's CMake. What does this mean? This means which type of package I want to create. Then by saying that I want to create a CMake package, basically this means that I'm going to create a package for C++. Yes. We are going to see it later, but in the case that we want to create a Python package, then the build type is going to be different. It's going to be Python, yes, instead of CMake. We are going to see that later. Then finally, we have the dependencies argument here, where we are going to specify some dependencies that we want to provide to our package. In our case, here the dependency is RCLCPP. Yes, basically this is the library that is going to allow me to program, to create ROS2 programs with C++. Yes. Also this, in the case of Python, it's going to be different. It's going to be RCLPy. Yes. But now, since we are going to be working on a CMake package, on a C++ package, we add the dependency RCLCPP. Yep. All right. Then the basic structure of a C++ package is going to be the following. Usually we are going to have the following. So now let me do one thing. Let me come here inside my package and do an ls. As you can see here, I have the CMake lists.txt file, I have an include file, I have also a package.xml and an src file. Yes. So this is the current structure that my package has. Then usually the most important folders that a package is going to have are the followings. So usually we're going to have a launch folder, which is going to contain the launch files. We are going to have a src folder, which in this case we already have, which is going to contain the source files. Yes, so the C++ programs that we create. Then we have the CMake lists file, which is a list of CMake rules for compilation. So here in this file is where I'm going to specify things for compilation. And finally, we have the package XML, which contains some metadata of the package. Yes, some metadata, let's say, package information, dependencies, etc. Yes, so these are the most common files that we are going to files and folders that you are going to find in a regular C++ package. Yeah. Then, all right. So what else? Then here, in order to check that our package has been created correctly, we can execute the ROS2 package list command. Yes, what does this command do? ROS2 package list. Well, this command basically is going to give me a list of all the ROS2 packages that I have currently in the system. However, as you can see, we have many here. So what I'm going to do is to filter again. So I'm going to use this grep, as I did before for the processes. I'm going to use this grep in order to find the name of my package, which is my CPP package. So let me execute it. And unfortunately, I am not being able to find nothing. So I have not found my package, because if it finds it, it would have showed me here the name in red, but it's not finding it. Why? It's not finding it. Can somebody tell me in the comments? Yes, no? Does somebody know why I cannot see the package? We have to compile. There we go, engineering. Have to build first. Okay, very well. So I'm going to do what you are telling me, so I'm going to compile. Now, where do I compile? Can I compile here? What do I do? Do I do a cat make, like in ROS1? This is not working. Colcon build. Okay, very well. Colcon build. So compiling a package. Let's move to the next section. So in ROS2, we are going to use the callcon tool in order to compile a package, yes? So this is the command used in order to compile a package. But as it happened in ROS1, we cannot execute this command anywhere. So we need to execute this command, this callcon build command, in the root of our workspace. In this case, it's ROS2 workspace. So we need to come back to the root of our workspace here. Yes? We need to be in this folder in order to compile. Yeah, ROS2 workspace. So once we are here in the ROS2 workspace, now we can execute the callcon build command. Let's do it. And let's wait a few seconds until this compiles. There it's compiling my package. There we go, excellent. Now, with the callcon build command, what I'm going to do is to compile all the packages that I have inside my SRC folder. Yes, so now I only have one, so it doesn't matter. But in huge projects, you are going to usually have many different packages inside your workspace. So for that, we can add the option packages select. Yes, by doing this, I can execute a callcon build, set the packages select argument, and then I can specify which package I want to compile. In this case, it's my CPP package. Yes, so it's going to allow me to compile only certain packages, the ones that I specify here. Yep. All right, there we go. Now, after compiling, I need to do one more thing, which is to source the install files. Yes, why? Well, because this is going to update let's say it's going to update the ROS2 knowledge, and it's going to include my newly compiled build package. Yes, if I don't do this, I'm not going to find anyways my package. So I need to source the proper setup bash file, which is inside the install folder. Yeah, so I'm going to do this, which is going to source my workspace, and now ROS is going to be able to find the packages that I have built, created inside my workspace. So now if I execute again that command, the ROS2 package list grab my CPP package, I'm going to execute it again, and now the system is going to be able to find my package. There we have it. Yes, here it appears in red. Yep. All right, excellent. Then let's keep moving. So I have created my package, but currently it's empty. Yes, so the package is empty. Now, so here we've been talking here a little bit about the typical folders and files that a package contains, which are package XML files, CMake list, SRC, and launch. Then all of these files and folders, I have them here inside my package. We can see them here, package, SRC, and CMake list. But what about the launch folder? We don't have it yet. Okay, so launch folder, it's going to contain launch files. Yeah, so the launch files are going to be the files that are going to allow me to start my ROS programs. Yeah, this is the same idea as in ROS1. In ROS1, we also have launch files. Yes, but there are some difference. The main difference is that in ROS2, launch files, as you can see here, are Python files. Yes, so they are actually Python files, and this gives us actually many advantages. Yes, but we are not going to cover them now, so because that would be too much. Then this is how a regular launch file looks. Yes, then we have the imports, so we need to import here the launch description module and the launch ROS actions. Then we need to add here a function which is going to return a launch description object. Yes, now inside this launch description object that I'm going to return, I need to create a node here with the following data: the package, which is the name of the package, the node executable, which is the name of the executable that I want to start to launch, And finally, we can specify the output, which can be a screen. We can set the output to a file, whatever. Yes, there are other options that we can add here, other attributes, other variables that we can specify here, but these are the most important ones, yeah? Especially package and node executable. Yes? Then, these launch files always are going to be placed in a launch folder. Yes? So let me create it right now here with mkdir. So all these launch files that I'm going to create are going to be placed inside the launch folder. So basically I'm going to have here the launch files, and here in the src folder the C++ files that I'm going to be creating, the programs that I'm going to create. Yeah? Alright, then in order to complete our package, let's create our first ROS2 program. Yes? So for this, what I'm going to do is to create a CPP file inside my package. So I'm going to do it here with the IDE. So let me open my package, and inside the src folder, I'm going to create a new file which I'm going to name, there we go, move_robot.cpp. Yes, as I have the name here. Then inside this file, I'm going to select here all this code that I have in the notebook. I'm going to select it, copy it, and paste it here into my file. There we go. So now here in the ID I have my file with the CPP code. Yes, so this is I'm not going to go into details on this. Maybe in next live class we will see a little bit more about this, but basically this is a C++ program, a very simple C++ program that contains a publisher. Yes, it contains a publisher that is going to publish messages inside the command bell topic of the type twist. Yes, as you can see here, is going to publish into the command bell topic. So what is going to happen if I publish into the command bell topic twist messages? Well, that the robot is going to move. Yes, so basically this is the purpose of this program. Yes, to publish commands into the command bell topic in order to move it. Yeah, okay, let's forget about this now, because this is not the topic of this live class. Then what else? Well, now I have my program, so now what I need to do is to create my launch file in order to start it. Yes, so I already have created the launch file, I already have it here. So what I'm going to do now is to create the launch file which goes inside the launch folder. Yes, here you have the instructions to do it from the web shell. You can also create it here from the IDE. New file, it's move_robot.launch.py. Yes, very important, because launch files in ROS2 are Python files. So even though my package is going to be a C++ package, yeah, so it's going to contain C++ programs, my launch file is going to still be a Python file. Yes, even though my package is a C++ package. Then now inside the launch file, what I'm going to do is to copy and paste the contents I have here in the notebook as well. Yeah, so let me select here this code, copy it and paste it here into my file. So as you can see, we have the imports, and here we are generating the launch description class with the following data. So the package name is my CPP package, which is my package. The node executable, it's move robot node, and the output is a screen. Yes, so this node executable, this is the node that I'm going to start, but I have not generated this node executable yet. Yes, so I need to generate it now. Then where I'm going to generate this executable? This I'm going to do it in the cmakelist.txt file. Yes, because this is the file that is going to allow me to compile properly my package and generate the executables. So next step is going to be to modify the cmakelist.txt file. Then let me open it here. Let me make this bigger, by the way, for a moment. There we go. Alright, so here I have opened my cmakelist.txt. Then here I need to add some things. First of all, as you can see here, you have a section which says find dependencies. Yes, and here we have these functions: find package, make, find package, rclcpp. These dependencies have been automatically created when I generated the package. Yes, remember that we specified the make build type, and we specify it as a dependency rclcpp. So here I'm going to add another dependency, which is going to be this one. And I'm going to add a dependency on this package, geometry messages package. Why? Because this package, I'm going to use it here in order to import the twist messages that I am using here inside my program. Yes, so I need to specify to add this as a dependency as well in the CMake list. So here I have it. I'm going to add it here below the others, and finally I'm going to copy the rest of the code I have here, and I'm going to paste it here right above the last line here. Yes, above the package function that I have here. I'm going to paste the rest. Yes, then here I am doing several things. So first of all, as you can see here, I am creating the executable. So here I am creating an executable named move_robot_node, and I am generating this executable from this source file, from the source file move_robot_cpp, which is the file I have here. Yes, so I'm going to compile this C++ program, and I'm going to generate an executable which is going to be named move_robot_node. Then this executable is the one that I am launching here in the launch file. Yes, make sense? Now what else? We are going to add target dependencies for this node, which are going to be rclcpp and geometry messages. Then we are going to install, we need to install this node into, in this case it's going to be installed into the install folder. Yes, so I'm going to install it here in my package, and finally here, down here, I'm going to install the launch files. Yes, so I'm going to get all the launch files that I have here, and I'm going to install them as well into my package, into the install folder here in my package. Yes, somewhere around here, lib. Yep. All right. Then I generate the executable here, and then I install this executable and I install the launch files. Yep. Alright, so now when I compile, all these rules are going to be taken into account, and my executable named move_robot_node is going to be generated and installed into the package. So here we have some explanations of what the different things do. You can have a look. Then finally what I'm going to do is to come back again here to the shell. Let me come back here, and I'm going to compile colcon build. There we go. So here it's compiling my package, 50%. You can see here the progress, 50%. The time spent, 0 packages out of 1 completed. I only have 1 package now, so it's still building, and 100%. Okay, so it has finished. Great. Now, very important to source the setup bash file inside my install folder. Yes, there we go. Then finally I can run my program with the following command: ROS2 launch, the name of your package, and the name of the launch file that we have just created here, which is going to start my node. Yep. So now if I run, let me make this a bit smaller here. Okay, so now if I run my launch file, my robot should start moving here, doing a circle in this case. So let me execute it and see if indeed the robot starts moving, and as you can see it does. So we can see here how the Turtlebot 3 robot has started moving here, doing a circle. Yes? Okay, excellent. Let me stop it However, now when you stop the program, you're going to see that the robot will still move. Yes, this is because the last command published into the command bell topic, it remains there, and the robot is going to be listening to that one. So in case you want to stop it, you can, here in the notes right below, you have a command that you can copy and paste here, and it's going to stop the robot. If you execute it, this is going to well, in this case, okay, in case you have this error, as you can see here, I am having an error. Yes, this might happen also to you. This might be a ROS1 message type, but it should be a ROS2 message type. Make sure to source your ROS2 workspace after your ROS1 workspace. Well, in this case, this happens sometimes. What you have to do is to come here down to the last note that we have here, and here you're going to see a command, an export command from of the Python path. Just copy this command, paste it here, and now if you execute again the command, it's going to work. Yes, so now I'm going to execute this command, and you're going to see how the robot stops. There it goes. Yeah, so now it worked. This is because sometimes the Python path here gets wrong, so we need to set it properly. There we go. Okay, so yeah, basically with this command, as you can see, what we are doing is to publish from the command line once a single message into the command bell topic, and we are setting all the velocities, the linear and angular velocities, to 0, so that the robot stops. Yeah, makes sense? All right, then let's go back here, and yeah, so basically we have finished the C++ section. Yes, so we have created a C++ package, we have seen the structure of the package, we have created a launch file, also a CPP file, we have generated an executable and launched it. Yes, so we have basically created a basic C++ package for ROS2. Yeah, then now we have 10 minutes until the class finishes, so these 10 minutes we are going to see how to do this in Python. Yes, it's similar, but there are some differences that you need to take into account. Yeah, so now let's create a Python package. Let me open again the shell. There we go. So again, here you have the equivalent command to create a Python package. Now remember, where should I create a ROS2 package? Here in the workspace root? No, I need to go inside the src folder. Yes, super important, be inside the src folder where I have my other package. Now here I can paste the command and execute it. This is going to generate the Python package. There it goes, and here it's going to appear as well in your src folder. Here I can see my Python package. So now, what does this command mean? Well, as you can see, it's the same, ROS2 package create. Here you specify the name of your package, which in this case we have named it my py package. The build type, as you can see, it's not amend CMake, but now it's amend Python. Yeah. And finally, as dependencies, I am specifying rcl-py, which is the library that is going to allow us to create ROS2 programs with Python. Yes. Now, as you can see, if you open this package, you can see that the structure is quite different from the C++ package. Yeah. So for instance, you can see that here you don't have a CMake list package file. Sorry. Here we have the CMake list txt file. In Python, you don't have it. Yeah. So there are some differences. So basically, the main differences are this one. We have as well a package XML. So this is the same as in a C++ package. It contains meta information about the package. Yeah. Now we have the setup.py file. So this file contains instructions on how to install the package. So this would be the equivalent of the CMake list file in C++. The equivalent in Python would be this one, setup.py. Yep, we are going to see it later, this file. We have also a setup.cfg file, we can see it here, which is required when a package has executables so that ROS2 can find them. Yeah, so basically here we are going to tell ROS2 where are the executables of this package. And finally, we have a folder which has the same name of the package. we can see it here. Yes, this is the package, my py package, and inside I have another folder named the same, my py package, and here I have a init.py file. Yes, then this is the directory with the same name as your package, used by ROS2 tools to find your package. Yes, so this is needed in order to have this package found by ROS2. And also inside this folder is where we are going to create our Python files, our Python scripts. Yeah. Then we have created our package, so let's create the same program that we have created in C++ but for Python. So the first thing I'm going to do is inside this folder, yes, so not inside the package, which is this one, but inside the folder which is named the same as the package, here alongside where we have this init py file, I'm going to create my Python script. New file, move_robot.py. There we go. Now inside this file I'm going to select here the code I have in the notebook and paste it. There we go. And as you can see, this is a Python script, also super simple. It contains a class named miniPublisher, which is going to publish into the command bell topic twist messages again. Here we have the values for the linear x and angular z velocities, so it's the same that we have done here in the C++ but in Python. Yeah, we are going to publish twist messages into the command bell topic in order to move our Turtlebot 3 robot. Yep. Alright, so we have created the Python script. Next we have to create the launch file. So Python packages also have launch files, of course. Then let's create first of all the launch folder, and inside I'm going to create the launch file, which is going to be named move_robot.launch.py. There we go. And now inside this Python, here I have the contents, but basically the contents are exactly the same as the launch file for the C++. It's the same. So let me copy the one I created for the C++ package, and I'm going to paste it here. So the only thing I'm going to need to change is the name of the package. Yes, so I'm going to change here the name of the package because now it's my py package instead of my cpp package. So the other is the name of the executable, which is moveRobotNode, but when we generate the executable for our package, we can name it the same so that we don't need to actually change the executable name neither. Yes, so I'm changing here the name of the package and I'm leaving the rest exactly the same. Yes, you also have the contents here in case you want to copy them. You have them here. Now what do I need to do? I need to generate the executable node, right? So for the C++ package, what we did was to modify, to add some code here in the semi-list file. Now in the Python package, what we are going to do is to modify the setup.py file. What do I need to do? Well, in the entry point section, which I have here at the end of the file, inside the console scripts, I'm going to add the following. So I'm going to copy it from here. I'm going to copy this section here, and I'm going to add it here. Yep. So I have added this line here. So what is this doing? Well, this is doing, hey, I'm going to create an executable node with this name, moveRobotNode. Yes. From where? From the file which is inside my py package folder, which is this one, my py package folder, inside the moveRobot Python file, and here we specify the main function. Yes, so when this executable is started, is launched, this main function is going to be executed. Yep. Makes sense? Then, in order to generate executable nodes, you need to add them here in the entry points inside the console scripts, like this. You specify the name of the node, of the executable node, the name of the folder that contains your program, the name of your program, move robot, and the main function. Yeah? Alright. So, let's keep going. And there is yet another thing that we are going to do in order to also generate the launch files. So for this, let's add a couple of imports, import OS and import glob here at the top of the file. In the import section, I'm going to import OS and glob. And I'm going to copy this line here, which is inside the tab. I'm going to copy this os.path.join. All this line, I'm going to copy it, and I'm going to place it inside the data files section, which I have here, data files. As you can see, we already have some things. So here, below, I'm going to add this line. Yeah, so basically this is saying, hey, all the files which have this extension .launch.py inside this launch folder. So inside this launch folder, all the files that have this extension .launch.py, I want to install them in the share folder. Yes, so I'm going to install all these launch files in the share folder inside this inside here the workspace. Yes. All right. So finally, we have here the setup.cfg file, which basically it should be correctly created when we create the package, but we are going to review it. Let's open it, and as you can see, it has the same content, so we need to make sure that these contents are there. So basically, this is telling the system to place the executable nodes in the lib folder, as you can see here. Yes. Hey, all the executables that you are going to generate, place them here inside the lib folder, because ROS2 will look for them here in this folder. Yes, so we have it right, we don't need to change anything here. All right, so now we are prepared, so we can compile our package. Let's compile it with well, let's move to the root folder here of our workspace and colcon build. It's going to start compiling. As you can see now, I have two packages, 0 out of 2, and it's compiling my CPP and my py package, and it has finished both of them. Okay, so I have compiled both packages. Then I need to source, set up bash file of the install folder. There we go. And finally, I can try to run again my program. I make this smaller. There we go. So I'm going to run. I'm going to launch from my py package. I'm going to launch this moverobot.launch.py file. Yes. So this is going to start my Python executable node, and it should start moving the robot. So let's see if it works as expected. And it does. We can see here how the robot starts moving. Yep. All right. So great. So far, so good. So this is all for today's live class. So basically, we have seen how to create basic ROS2 packages, both for C++ and for Python. And we have created some basic programs to test them, launch files and executables. And we have seen the main differences from creating a C++ package and a Python package. Yes, like this CMail list file, the setup py, some important differences that we need to take into account when working with ROS2 packages, depending on if they are C++ packages or Python packages. Yep. All right, so yes, guys, that's all for today. IDE fixed, can't seem to load the IDE after refreshing, says Engineering Nations. IDE fixed. Yeah, sometimes it takes some time. to load the IDE, or it has some strange issues. And we have to compile, yes, soup, have to build first, okay. So yes guys, this is all for today's live class. I hope you have enjoyed it. I hope you have learned something new for this hour at least. And yeah, thank you very much for being here with me. Let me see, I have a question here. In ROS1, you could create C++ and Python code in the same package. Can you do this in ROS2? If not, is there plans to add this functionality? Very good question, Zach. So currently, that's not possible. As far as I know, that's not possible. Yes, I will need to do some research. How is everything currently? But as far as I know, that's not possible. But I suppose that there is going to be some plans in order to add this functionality. Yes. However, I'm not sure. So I will need to see how is the latest status on this. But yeah, maybe Zach, if you come to next live class, I can answer to you this question with more research. I will do some research later, because this is a super interesting question actually, and I want to do some more research to see how is the current status of this. All right, so yes, thank you very much, guys. So next Tuesday, we're going to have a live class also on ROS2. Still not decided the topic, but I don't know. Maybe we can focus a little bit more on creating programs like publishers, subscribers, services for ROS2. I don't know. I'll think about it. But it's going to be, again, we are going to continue with the ROS2 theme. Yes. So yeah, guys. Thank you very much. Take care, as I always say, and keep pushing your ROS learning. Bye bye. What are you doing, Alberto?
I'm training this intern with ROS.
Oof. Did you have the same experience? Spending too much time equipping your team with ROS skills? Check out our ROS Online training solution for enterprises, a fast and easy way to empower your team with ROS. From ROS basics to manipulation, perception, AI, ROS2, everything your team needs to learn is here. Practice with real and simulated robots. Train your team by doing from day one. Also, our ROS experts will provide you 1 hour of consulting services to boost your robotics projects.